to the square root of x, y is equal to x minus 2, and x axis. Okay, so we have these three graphs that we have been given. So remember, this is the y-axis and this is our x-axis, right? And now we want to find this area bounded by the three curves that we have been given. X is equal to the square root of, y is equal to the square root of x, y is equal to x minus 2, and x and the x-axis. Okay, so we can start by graphing this one. Y is equal to x minus 2. Okay, this one, if you want, you can go direct. Okay, you can go direct because you know the equation for the for this one. Y is equal to x. Okay, you know it will pass at the center to the positive sides, and then there is a shift in the x-axis 2 units, okay, to the positive sides. Okay, so if you know what I mean by that, you can go ahead and do that. Okay, or you can check my videos on shifts, okay, on graph shifting. Okay, but we're going to use the simple method, very easy to understand. Okay, remember what we have here, y is equal to x minus 2. This is a linear equation. Okay, so we can make use of the box. Now in this box that I've drawn, the upper row, I have my x values that I'm going to assume, and the lower row there, I'm going to assume the y values. Okay, for each y value I assume, I can find the x-axis. For each x-axis I assume, I can find the y value. Okay, so for the x values, using this equation, let me say we can assume the x to be 0. Okay, if x is 0 in this equation, what will be my y? My y is going to be negative 2, right? What if I assume my y to be 0? What will be my x? Okay, if y is 0 there in this equation, then my x is going to be positive 2, right? Okay, now we have those coordinates, the first column and the second column. We have 0, negative 2. That means negative 2 here. Okay, we are just sketching, so you can just estimate that negative 2 is there. And then our 2, 0, okay, we can assume it's there. Okay, so this is 2, 0. Okay, and we can draw the graph for this one. Okay, we can draw the graph. So the graph is going to pass at these 2 points. Okay, okay, like this. All right, and now we can graph this other one, that is okay, so this equation, okay, this, the one we have just drawn here, is y is equal to, okay, y is equal to, that's x minus 2. Okay, this is the graph. Now we want this other one, that is x, that is y is equal to the square root of x. Okay, so that one we can sketch. We know how the graph looks like. Okay, it's this one here. All right, so this graph looks like this. Okay, this is the graph for the equation y is equal to the square root of x. Okay, so we have this one again, and the equation, okay, let me just use another color so that we can see the difference there. Okay, so the equation here is y, okay, is equal to the square root of x. Okay, so we have done that. So the area that we want to find is this one. Okay, okay, this is the area that we want to find. Now how we're going to do that, we're going to use two methods. We're going to use single integration and double integration. Okay, to use single integration, we need first to find this point where the two curves are intersecting. So how we're going to do that, we need to calculate this one. Okay, so we can solve it from here. All right, so we have two equations. remember we have equation 1 as y is equal to the square root of x. Okay, we can let this be our equation 1. Okay, and then we have okay, let's do this. We know that this equation here, that is equation y is equal to the square root of x. Okay, this one can also be written, okay, as y squared, right, is equal to x, isn't it? Yes. So this, we can let this one be our equation 1. Okay, we have just write this in another form, and we have y squared is equal to x instead of y is equal to the square root of x. Okay, and then we have y is equal to x minus 2 as our second equation. Okay, so this one is equation 2. Okay, so to solve these two equations, we can substitute equation 2 into equation 1. Okay, so we're substituting equation 2, right, into equation 1. Okay, so if we do that, what we are going to get is x minus x minus 2, right? You close, then this will be squared. Now you are going to get is equal to x. Okay, now there you need to expand x minus 2 is equal to x minus 2 squared. Expanding that, you are going to get you are going to get x squared, right? So you are going to get x squared minus 4x, okay, minus 4x plus 4 is equal to x, right? And now collecting your like terms, you are going to have x squared again, okay, minus 5x plus 4 is equal to 0. Now you can solve this one by factorization method, okay, finding the sum and the product there. Okay, now if you use that method, what you are going to get is negative 5x, negative 4x, I mean. Okay, you are going to have negative 4x minus x plus 4. Okay, if you don't know how what I've done here, you can check through my videos, okay, and look for the videos on factorization method. Okay, yeah, that would be helpful. Okay, so factorizing, if we factorize here, what we are going to get, we're going to get x, right, minus 1. We're going to get x minus 1 and x minus 4, right? So this is what we are getting now is equal to 0. Okay, now solving this one, we are going to get x is equal to 1, or your x is equal to 4. Okay, so we can see the value at which these two graph are going to have the same x values is at x is equal to 4. Why do we say that? Look at this point here. Okay, this is the x-axis, where we are saying this would be y is equal to, x is equal to 4. Okay, because at this point in the x-axis, the graph has already passed 2, right? So where they are meeting here from our solution is at x is equal to 4. Okay, so if x is equal to 4, substituting back in the equation, y is equal to the square root of x, that is, if you substitute your x value into this equation, you are going to get what you are going to get is 2, right? That is the square root of 4. That will give you 2. So we are getting 4, 2 as the point of intersection for these two graphs. All right. Okay, so using single integration as the first method, okay, using single integration, we are going to solve, okay, for the two for the area, this shaded area, you are able to see it. Okay, now what we are going to do is we are going to integrate okay, we are going to integrate the x-axis. We are going to integrate the graph, that is the graph which is x, the square root of x. We are going to integrate this with respect to x, okay, from 0 to 4. So we're going to do that from 0 to 4 with respect to x. Now if we do this, the area that we are finding simply by integrating the graph or the curve y is equal to the square root of x is the whole area, okay, under this curve, okay, including this part here. Okay, so the strategy that we are going to use, because doing this integration, we are calculating the entire area under the curve from 0 to 4 in the x-axis, okay, up to that curve, which is involving the part of the area that we don't want. Hope you are able to see that part of the area which we don't want. Okay, are you able to see that? Okay, let me show you. So there is this area, okay, this part, this triangle here. We don't want this area, okay, it's not included in the area that we've been asked to calculate. Okay, so what are we going to do? After integrating here, we are going to subtract this area of a triangle. We know by the formula for the area of a triangle is half multiplied by BH, that is the base and the height. So if we do this, then we would have found the area, okay, bounded by those three curves. Okay, let's go ahead and do this. Okay, so this is method 1 that we are going to use, where we are using single integration. Okay, we can go ahead and integrate this part. Okay, so if we integrate this part, we are going to have that's 2 over 3, right? 2 over 3, open bracket, that is x, that is your x. What are you going to have here after integrating? This is 3 over 2, right? Okay, now remember your limits is from 0 to 4. Okay, so these are your limits, that is from 0 to 4. Okay, now we are subtracting the area of that triangle. Now what is the base for this triangle? So this triangle, the base is from 2 to 4. Okay, the difference there is 2. Okay, what about the height? Okay, the height there is 2. You can see in the y-axis. Okay, there what we are having is 2. Okay, so the height of this triangle is 2 units. Okay, we know that if we apply cancellation rule there, we're just going to have 2. Okay, right? And then this side, if we substitute, we are going to have x to the power x, that is 2 over 3. Okay, substituting x with 4, we are going to get that's 4, right? That's 4 to the power 3 over 2, right? Minus 0. Hope we're able to see why this is like that. Okay, because when we substitute with 0, x with 0, we're going to get 0. Now minus 2, we are remaining with 2 this side. Okay, okay, now what are we getting here? Okay, what you are getting here, okay, let me not skip this stage, let me show you what this means. Okay, this means you want the square root of 4, right? We are using the rules of indices here. Okay, you are finding the square root of 4. Now that square root, if you find it, you need to square it. You subtract 0, you're going to get the same thing, and hence we're just going to subtract 2 there, right? Okay, now if you do that, what you are going to get here is 16. Okay, remember we are going to get square root of 4 is 2. Okay, so 2 cubed, that will give you 8. 8 times 2, that will be 16. So 16 over 3, right, minus 2. Okay, now doing this again, okay, find the lowest common denominator, which will be 3. That will give you 10 over 3. Okay, so this is the area bounded by the 3 caves that you've been given. All right, so this is the first method that we have used. Okay. All right, now the second method that we want to use is the double integration. Okay, that is double integration. Now to do that, again, for double integration, let's do it quickly here. Okay, now for double integration, that means we are going to use change of variables. Okay, so it means we are going to change variables. That is, we are going to use the what we call horizontal strip. Okay, sorry about that. We are going to use the that is the vertical strip here. Okay, all right, so we are going to use the vertical strip there. Okay, that means we are going to integrate we are going to turn our limits into x values. Okay, so what we mean by that is this equation, which is y is equal to x minus 2, changing the variables. Okay, this will go to x, right, is equal to, that is x is equal to, okay, that's y plus 2. Okay, what about this one? Okay, we want to change our limits into x. Okay, these are the limits that will be in the x, and that will be for the x. Okay, and then here changing this one, okay, that is making x the subject of the formula. We are going to get that is x is equal to y squared. Right, that is y squared. So this is what we have. Okay, all right, so since we want the area now, okay, from we want to use double integration. Okay, at this point we want to use double integration. That is method 2. Let me just write here. Okay, so this is method 2. So we have the limits for x, right, that is from, we are coming from that graph. There's a mistake here. Okay, just a bit here. I made a mistake. We are going there, we are using the horizontal strip here. Okay, and not the y-axis. Sorry about that. Okay, because double integration is about knowing your boundaries. So we are using the horizontal here. That is, in the x-axis, the limits are coming. Okay, we are coming from the graph in this case, which is y is equal to x minus 2, which we have changed to be the x limits, which will be x is equal to y plus 2, right? That means we are using the horizontal bar strip. Okay, you can find out more information about a bar strip, okay, when it comes to integration, or you can comment on this video and then I can create one for you just to explain more on that. Okay, so using the horizontal bar strip, so we are coming from the curve, which is this one, which is x is equal to y plus 2. It has changed now. Okay, we are coming from x, that is x, okay, is equal to, we have changed the variables, y, okay, plus 2 to this line here, okay, which is that is, which is okay, not this one here. Okay, this equation, okay, this graph on top here, this graph on top, Okay, let me just do this. This graph on top is the one here, okay, which we have changed to x is equal to y squared. Okay, that is x is equal to y squared. This is the one. Again, this one here still remains the same, but the variable is x, so x is equal to y plus 2. So I hope you are able to see that now. So in the x-axis, we are moving from x is equal to y squared to x is equal to y plus 2, right? What about in the y? In the y-axis, remember, from in the y-axis, this is 0, right? This is y is equal to 0, and then y is equal to 2. So we are going to use this. So we can now integrate using double integration. Okay, so we have integral for x, that is we are integrating, right? That is from, for the x limits, we have y, right? We have y plus 2 and y squared there. Okay, that is for the x. We have dx there, and then for y, which is dy, so we have dx dy, starting with dx. Now dy, the y limit is from the 0, the line y is equal to 0, to the line y is equal to 2. Okay, so let's see if we're going to get the same answer for the area that we found by using single integration, and this method 2 where we are using double integration. All right, okay, let's go ahead. We have that's 0 to 2 there. Okay, so we can integrate inside. Okay, if we integrate what is inside, that is with respect to x, we are going to get that's simply x inside, right? Then we have y plus 2. Okay, we have y plus 2, and then we have y squared here. Okay, dx, that's dy, sorry. Okay, so we still have this. Now we need to substitute that x with our limits. So our limits, we are going to get y squared, subtracting the lower limit, which is y plus 2, right? Y plus 2. Now dy. Okay, now we have to subtract this to dy. We have to integrate now this with respect to y. Okay, now doing that, what we are going to get is y cubed. Okay, so we're going to get y cubed there by 3, right? Then minus y squared, so we are using integration here, that's 2, right? Then minus, is it minus? Yes, that's minus 2. I remember this has to be put in brackets. Okay, so we are multiplying this negative by everything inside the brackets. That will give us a negative 2y. Okay, now the limits is from 0 to 2, right? So doing that, what we are going to get is, we substitute with 2, you are going to have 2 squared, that's over 3, right? That's cubed here. Okay, that's cubed. Then minus, we have this one. Okay, we substitute with 2. Now this one is squared, that's over 2, right? Then minus, okay, minus, what we have there, it's 2, substituting with y, which is 2 again, right? So this is what we have. Okay, now everything minus 0, we know that we are just going to get 0 here, okay, outside the brackets. Okay, so we know that here we're just going to have minus 0, right? So what are we getting from the inside here? Okay, if you do that, what you are getting, you are just going to get 4 minus 24. Okay, I know you can't afford to do what is in this stage. You can do that. Now when you do that, you are going to get that's okay, sorry. So you're going to get that's 4 there. Okay, that's 4 minus 24. That's 4 minus 24 over 6, right? Which is going to give you that is negative 20. Okay, that is negative 20 over 6. Okay, now you take the absolute values for this one. Remember, this is the area that we want. So taking your absolute values, what you are going to get is simply 10, okay, over 3. Okay, so we are getting the same area. Remember, this is the area using double integration for the same region, okay, that we were calculating for in the first video, okay, which is right here. So we found there to be 10 over 3, and here we have 10 over 3, okay.